Cool. Hey, everyone. I'm Nick. I work on the Project Kuiper, Amazon Leo team. We rebranded, about a week ago. So I may say that a few more times, but yeah, we're building satellites. So we're here to talk about sort of what we're building, what we're doing with AWS, and John's also going to talk with us.
Hey folks, I'm John. I've been with Amazon for about 11 years now, helping to build the network on the AWS side.
Great. I appreciate all of you coming to the farthest flung part of this conference at the latest hour. So I just appreciate all you guys from being here. So what we're talking about today is Amazon Leo. We're building a satellite internet service. It's going to be a global service around the world. And we also are here at the AWS conference, and AWS runs a global computing solution. So the answer is, what does it look like when you use these things together? What are the benefits? What are the use cases? Those types of things. And one of the interesting parts of working for Amazon Leo is we're a space company. And I've been working on the cloud side a lot too. And sometimes you're working enough things named after planets and other things that you think you're working on space stuff too, but not really. You're just working on billing for containers or something. And so I think we've been teased about space enough. So let's watch an actual rocket launch.
minus 7 minutes. Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Centaur systems, propulsion. Go. Pneumatics. Go. LO2.
Go.
LH2.
Go.
Anomaly chief. Go. Launch director.
You have permission to launch.
Proceeding with the count.
3, 2, 1. We have ignition and liftoff. Parameters continue to look good. We are now moving at 4,000 miles an hour.
Flight software looks nominal. Mechanicals proceeding nominally.
All Kuiper satellites have been deployed successfully.
Congrats, Kuiper.
Great. So this is a little bit of what our constellation is going to look like. So we've got plans to launch over 3,200 satellites into low Earth orbit. Low Earth orbit is also the name of our brand with Leo, so it's very clever. And so we're launching at 3 different shells between 590 to 630 kilometers up in space, which we'll talk about. One of the interesting parts that we'll also talk about is everything goes up must come back down. So you have to build a global ground gateway network. And so all of those things, when you add it up together, your user experience when you use it will feel a lot like a fiber or cellular network, right? So we're estimated in around less than 50 milliseconds of latency, and our ultra largest terminal can do a gigabit down and 400 megabits per second up. And so you can get high speeds, low latency, and that's what we're building here. Usually the first question we get is, how ready are you? Where are your satellites? What's the status? So let's just cover that now. So over the last 6 months, we have launched roughly every 6 weeks, putting anywhere between 24 to 27 satellites up at a time. So we got 153 satellites up in space. In 2026, that cadence is going to increase. So we have facilities down in Cape Canaveral. We're going to be able to work on multiple missions and multiple launches at the same time. We're also working with vehicles that we paid for many, many years ago and are just now kind of coming online. So the Blue Origin New Glenn, the new Ariane 6, as well as the Vulcan Centaur with ULA. Those are all bigger, badder rockets, and they launch more satellites up at a time. So our pace is going to increase, and we're all super excited about that. So we should have service in 2026. If you take a look at this image in the center, this is a still shot of one of the many, many simulations that we run. And this shows you a little bit of the effects of our orbital mechanics. I'm not going to tell you too much about orbital mechanics, but we'll get a little bit into it. And so essentially, we put the satellites into an angle around Earth. But the way that it actually kind of shows up is it doesn't spend the same amount of time at every latitude. It kind of spends more time at the tops and bottoms. And so the way that you will see service roll out is the closer you are to these kind of areas that are unfogged, is the sooner you'll get service. So for those of you that maybe geography isn't your forte, essentially there's that line kind of goes through the US-Canada border, and that also kind of goes through Central Europe. And so that's the first areas where you'll see service come up. And on the south, we start kind of down in New Zealand. It's mostly ocean, and then comes up towards the equator. So you'll see us roll out over time like that. So what we're going to talk about today is why go through all this effort? Space is hard. What are the challenges and problems that we're seeing? I'll teach you a little bit about how the satellite network works. That way you can understand how to use it better. We'll talk about how we're working with AWS and where the overlaps are. And then some of the use cases and what we're seeing from customers and how actually people put this into practice. So let's talk about some of the challenges here. Typically, we see the problems they're based on how far you are from other options. So let's start close to fiber in the city, in the urban areas. So the challenges we see here are, you've got pretty good fiber, you usually have multiple providers, multiple options, until you don't. And so if storm comes through, you have an outage, you have hurricane, flood, bushfire, whatever your location suffers from. And so, our terminals are meant to be outside, they're hardened, there's a pretty good chance they'll live through this. Otherwise, you pop one open from a backpack, and now you can connect to the LEO network on demand. So there's some use cases there. Then you kind of get a little bit further out into some more kind of suburban kind of areas. This could be 2 miles or 20 kilometers. Every kind of part of the world's a little bit different. Out here, you have less options. So you may think, for example, that you have 2 different providers that are fully separated until our friend, the fiber-loving backhoe, shows up. And it cuts a channel, it cuts a bridge, wherever it is, and now you have maybe 0 options. Or maybe the options you do have take a couple months to show up, and you need connectivity faster than what people can provide to you. So we see a lot of use cases in this kind of suburban area. We get a little further out. Now we're in kind of areas where satellite communications are more typical. So this is your agriculture, your mining, your far rural areas. When you're out here, everything is harder and more expensive. People's lives can be at risk. The equipment is expensive. The things you're doing are important. And trying to connect those things and make sure they run like they're close to home is difficult. And then you get even further out. Now we're in airplanes and boats and islands. These are places where you just don't expect to have internet, maybe at all. And so there's a lot of things, a lot of different use cases we can do out in these areas that now it's also something we can do. And kind of no matter across the board, one of the challenges we see is just the management of these systems. Sometimes these systems were built for a single country or a single niche use case, or you're working with 30, 40, 50-year-old type of equipment, and it doesn't have the types of monitoring and management and ease of use that we kind of expect in the cloud world. And so it can just be challenging just to manage these things. So when you add some of these things up, these are some of the bases that we think that Amazon LEO will be different. We're not the first people, we won't be the last, but we think this is what's different about what we're building. One is the performance. So we're a connectivity service, and that's just what people care about. So performance is paramount. So anything we can do to reduce latency, increase bandwidth, but also the consistency of that, right? Running a high quality network, doing it securely, right? So being secure by design is our kind of second area. Amazon in general has a very high security bar, and so we meet that. But we've also, as a connection that you want to use and businesses that want to use this, we make sure that we've increased the security of our network. So we have an advanced encryption across our network, and we also have options that keep it completely off the internet. So we can do private networking options. And then, being ready for business, the way that customers want to be treated, invoicing and management at scale and customer support and just things you expect from Amazon are things we do. And one of the other interesting parts of working for Amazon LEO over the last few years is all the other things Amazon can bring. So if you think about our retail business, right? The ability to ship antennas around the world quickly and have return logistics for that. The ability to manufacture devices, like the millions of Fire TV and Alexa devices. We've got a lot of experience with that manufacturing portion of it. We need to build millions of terminals and thousands of satellites. There are a lot of overlaps there. Both AWS and other parts of Amazon have built custom chips and ASICs. We built a lot of those into our system to make sure that we get the right price and performance on the satellites. You get into the cloud side. One is a lot of the workloads customers want to use in combination with Leo are running on AWS. So you can combine your connectivity and your applications together in ways that you benefit from. But also just like the process of designing these things. We'll talk a little bit about like why Leo is hard and difficult, but like control planes, multi-tenancy, building like strong APIs are things that AWS and Amazon have done before. And so there's a lot of really cool things we can use from Amazon to make Leo better. So a bunch of things we can learn here. I'm just crowd check. How many are networking folks? How many of you guys are like astronauts or space people? A couple, all right. How many of you guys are like developers? All right, that's kind of what I expect. So I'm going to teach you some orbital mechanics real quick. So GEO, which is short for geosynchronous orbit, this is basically a way, it's a simple business model is what we're doing here. So an orbit is really just a fancy way of saying you're trying to fall back to Earth using gravity and you're missing and you're just kind of flying with style. So what geosynchronous really is you're at a very specific distance. So if you're 35,768 kilometers from the Earth, you're falling in a way where you're just rotating at the Earth's rotational speed. So this means if you're a country and you want to launch one satellite and it's over your country all the time, you put it exactly this distance away, right? And so if you've seen like, I don't know, watch TV on your sort of aunt's dish in the country and it takes like a second or two for everything to get by, or if you've ever done a sat phone call and you have to kind of make like walkie-talkie sounds because the delay is so long, that's because you're going a very far distance into space and coming back. So that can be 250, 750 milliseconds, just depending upon how they run the network. So we go, okay, well, let's build this in Leo. I actually did make these like fairly accurate for physics, so we'll see if PowerPoint crashes. But now with Leo, we're a lot closer to Earth here, right? So the latency, it could be anywhere between 15 to 100 milliseconds, depending upon things like the angles. If you're using lasers for things like things that move or airplane flights, or just again, how you run the network. So now we're going around the Earth 16 times a day, right? And you can also see the beam is a lot smaller, so we're not covering very much of the Earth. So now we need more satellites. So I couldn't fit more on this slide, but even now with like 50-ish satellites, we're not covering the whole world at any given point in time. But we've got a lot more control now. So the beam is smaller, we're losing less of that energy and that physics to free space. And if we don't want to, we don't need to turn the beams on over the oceans, and we have a lot tighter, more granular control. We're also within the Van Allen radiation belt. So this means we actually get more built-in protection from being closer to Earth. And so, again, some of you guys are developers, it's like the difference of like running a single Postgres database in your closet versus running like a full high-performance scale cluster, right? Now you can think about, as these move around, there's a lot more handovers, there's a lot more thinking, there's a lot more complexity in systems like this, and so you need to take sort of a cloud scale design to build this network. So let's take a look at the packet walk and just a little bit more detail. So we start with the antenna. It's built to be outside. It's going to talk to a satellite in space. That satellite is going to come back down to a ground gateway. And then that ground gateway is going to send it to one of our points of presence. We used to be called Kuiper, and these used to be called K-pops, and so there was a lot of good Korean jokes. Those are now gone. So these are just our points of presence. That point of presence can send it either to the internet, directly to AWS, or to a private network interconnect. If we zoom in a little bit on the antenna, let's spend some time there. So one of the interesting parts of Leo is we've spent a lot of time, and a lot of effort, a lot of our engineering, and a lot of the trade-offs we make is to make the antennas really good. As opposed to paying lots of money for expensive things, these need to be built in an Amazon style, right? So they need to be rugged, they need to be outside, but we need to make sure these are as affordable as possible. If you think about a lot of the parts of the world that don't have internet, affordability and the entryway cost is extremely important for us. And so these antennas, there's a radome on top that protects it. Underneath, inside is a phased array antenna. Underneath, there's a heat sink, and then there's an Ethernet port. That's pretty much it. But there's a lot of really advanced technology in there. And so these three units we've got here, the Pro, the Nano, and the Ultra. The Pro unit, it's about the size and weight of a laptop, and it does 400 megabits per second on the downlink. The Nano unit is even smaller. So that's 7 inches by 7 inches. It does 100 megabits per second. And so this is really about the size, the weight, the power. You want to put it in a backpack, or you want to put it someplace where maybe you're doing SCADA or IoT type monitoring or surveillance, or just a small amount of users. And then you have the Ultra, that's the big boy. So this is what we see for more of our heavy enterprise use cases. It's around 40 pounds and it's about this big, so it's a little bit bigger. But this is also, you kind of think about like data center class. If you want to back up a data center, or you have a lot of users, you have a camp with 400 people, you want that full gigabit, this is the unit you're going to want. And so, let's keep moving here. So let's talk about the satellites. The satellites get a lot of attention because they're in space and they're pretty cool. So they move at 17,800 miles per hour, or 28 kilometers if you like other types of units. This also means they're only over a certain part of Earth for 30, 60, 90 seconds usually, just based on the speed that they're going at. Which means one of the interesting things that we do from the networking that we build is it's all pre-programmed. So the hard part about getting things into space is getting there. The easy part is predicting where it's going to be in the future, right? So these orbits are highly predictable. We know where those are going to be. We know where the terminals are going to be. We know where the ground gateways are going to be. And we can pre-calculate all those topologies. There's also lasers as well, which we'll talk about. So we can figure out what the network needs to look like, which frequencies are used where, which terminals are going to talk to who, when they're going to hand off, and we can be extremely accurate with those things. So it's a really cool network engineering project. When I say they're predictable, some of the things that are not is they do sometimes need to use the propulsion. So we have propulsion on board. This allows us to do a couple different things. One is we can come in at a lower altitude, raise the orbit once it's tested and it's clean and good. Also on orbit, if there's any chances of debris or other things we need to do avoidance maneuvers, we can do that. And once the satellite is done, we slow the satellite down and it burns up peacefully in the Earth's atmosphere. So we can talk about sustainability in a lot of different ways. Essentially, we're doing a lot of work there. That's usually the first question we get. Cool. Let's talk about the lasers. So lasers have a couple different use cases. The first and kind of probably most obvious to folks is, hey, you're out in the middle of the ocean, you're on a boat, you're on an airplane, and there's no ground gateway near you. So the lasers allow us to have a greater reach. So you go up to the satellite, you go pew, 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 pew. I'm legally required to do that. And then you come back down to a ground gateway. And so it's about the reach, but also, if that ground gateway has an issue, or if there's a storm there, or if there's a fiber cut, or if there's antennas having issues, you can use those lasers to get to more options. So it gives you optionality in how you build the network as well. So yeah, they have 4 different lasers. They can go kind of north, south, east, west, and you can build this kind of flexible, kind of like, think of it like a space backbone. And it gives us some options on how to route our traffic. Then we have the ground gateways. So this is a picture of those. Usually they're going to be, 5 gateways just hanging out in a field somewhere. And these are super important for us. So if you think about, there might be hundreds or thousands of these terminals on the left, and the satellite's talking to, 1 or 2 ground gateways. So it's kind of, in networking terms, it's your uplink. It's very important for the overall network bandwidth. This is also how we'll eventually, reduce all the latency. So the closer that gateway is to where you want to go, you spend less time messing around in space. And so this scales out. So this is where we use the AWS network. We need to put that gateway somewhere near a network to get it to where you want to go. And so that's part of what we're going to talk about here. So the gateway basically takes the RF and puts it on the ground network. You think about space a lot, but most of the latency, most of the hard parts of this actually are just typical ground networking. And then we get to the POP. So the POP then can make a routing decision. So you can take that if you're running maybe a workload you don't want to touch the internet, we can take that directly into your AWS environment. If you have a data center or another cloud you want to work with, that's where we would do a private network interconnect. We can do a peering with you, and you can take that traffic privately there. Otherwise, you can go to the internet. That one's pretty straightforward. So now you guys are all satellite experts, which is great news. But there might be some challenges that are still a little bit hard to sort of visualize. So one is just building a global network is difficult. So we have to do this in many, many places, all kind of at the same time. And Earth is just kind of a large place. So there's a scale problem, and this is all to talk about, like, some of our networking challenges, which we're going to get into. So then it's about performance. Okay, you're going to space and back. You have to do this globally everywhere. But how do you also reduce the latency and increase performance? Because again, that's what people care about. And you kind of want to design it once. You think about your cloud design. You don't want 16 of those. But building in a small country in Africa is much different than building in a large country in Asia versus something down in South America. And so we have to make a lot of different choices about where we're at in the world. Sometimes it's based on their local laws and regulations, or sometimes it's based on just the demand. So think about us needing to choose, do we use the AWS region? Do we use the AWS local zone? Or do we use AWS outpost? And that's sort of like all those choices we need to make. And then there's making this a global, easily managed network across the world. If I have 1,000 terminals and they're spread across countries, how do I do this using like that sort of cloud scale management that we all want? So to give you an idea, right? If you have to design the Leo network and you want to put the first 8 gateways, you can kind of figure that out. Some places where we'll have coverage, places where we have demand. There's some obvious places to do this. If you're building 300 gateways, where are you going to put all those things, right? And so this is an example of one of the networking challenges. If you decide you want to build a Leo network as well, that you'll have to solve. And so for us, there's a big advantage for using the AWS network. And so to help you guys understand that and what it looks like and why we've done this, John's going to come up and talk about networking things. Thanks, John.
Yeah, thanks, Nick. Hey folks, my name is Jonathan Philibert. I'm a principal network development engineer in the AWS Global Infrastructure Services space. I work on a team called Internet Edge. It is exactly like it sounds. I work on the parts of the network very close to the internet, way out at the edge, away from the data centers. One of our favorite things to do is work with the people that are building the services on AWS. Hearing about their unique challenges, especially when we get to help solve some of those challenges. That's how we started working with Amazon Leo. They were facing some unique challenges, and by building on AWS, they were able to accomplish some pretty cool things. So yeah, I'm here to introduce you to Internet Edge, some of the unique things that we offer, and how Amazon Leo was able to leverage us to build a highly resilient, highly performance, and very secure service. So if you've been to some of the AWS Global Infrastructure Services presentations before, you may know that we run a very large network. It didn't start that way. It actually started very modestly, way back in the early 2010s. Back then, we were sending traffic out over the open internet between the regions. Didn't really provide the kind of experience that we were looking for. It wasn't very reliable. It wasn't very performant. So we started on this journey to build a backbone. As the story goes, it is now massive, right? It now interconnects our 38 regions globally with over 200 Internet Edge points of presence that we use to exchange traffic with the internet. This also includes our 145 Direct Connect POPs that we use to exchange traffic with on-prem networks. This is distributed over 100. It was distributed over 110 metropolitan areas in 58 countries. All said and done, this allows us to exchange traffic with over 5,000 internet peers. When you take redundancy into account, it's a lot of capacity for the internet. When all this capacity, when all this interconnection is laid out on a map, this is what it looks like. It represents over 9 million kilometers of terrestrial and subsea fiber optic cabling. It's a lot of cable, it's a lot of fiber. It is actually enough fiber to loop between us and the moon and back more than 11 times. What's even more phenomenal is the growth that we are experiencing. We're adding more fiber to it every day. Just in the past 12 months, we've experienced an 80% growth. This growth has made it vital that we invest in automation. The network is just too big for humans to manage by themselves. So 96% of network events are remediated without a human ever being involved. You may have also heard that Amazon takes security very seriously. This applies to the network too. When we were designing it, we wanted to make sure that security was first. It was designed with security in mind. We've done that by utilizing a technology called MACsec. It's a layer 2 encryption, and we use it by encrypting data between the regions, between the data centers, at very close to the physical layer when they leave secured AWS locations. Since we do have this secured internal network, we wanted to make sure that the workloads running within AWS benefit from it. We do that by ensuring that the traffic stays on our encrypted paths. When traffic between the regions should stay inside Amazon and never go out to the public internet. All that fiber I was talking about means that we should always have enough internal capacity available to fail over to, rather than sending traffic out to the open internet. Of course, there are workloads within AWS that do need to speak with the internet. We've thought long and hard about how we can improve the security and the reliability of that type of traffic too. One of the ways that we've done that is using Resource Public Key Infrastructure, or RPKI. It allows the participants of the internet to cryptographically verify that the routing information they receive is accurate and legitimate. It helps prevent traffic from taking unintended or unreliable paths as it is routed across the internet. You know, it seems like ancient history, but it was probably like 2 or 3 years ago where it seemed like every week we were detecting our traffic taking unexpected paths. But you know, lately, more recently, RPKI has done a phenomenal job of preventing these events. It allows these networks to detect the bad routing information and ignore it and drop it, ensuring that traffic only takes reliable paths, the paths that we expect when it goes across the internet. We've also done some pretty cool things with traffic engineering. We monitor traffic as it goes through the internet. We collect metrics. We collect reliability information and statistics around performance. And we use that data to make decisions about where we should send our customer traffic. We ignore sometimes the typical routing protocols that run the internet and instead make our data-backed decisions. So the people who are building on top of AWS, they just want to focus on running a great service. They don't want to have to worry about what it means to use public IPs and accept connections from the internet. Unfortunately, the internet doesn't always work like that. There are bad actors out there that will find a service and just throw junk packets at it in a bid to disrupt or deny a service to your users. We call these distributed denial of service mitigation attacks, or DDoS attacks. That's why we have AWS Shield. In each of our more than 200 facilities where we peer with the internet, we have deployed our custom homegrown hardware that will detect this traffic. It will then redirect it, drop the bad traffic, and then allow the good traffic through, ensuring that your service is uninterrupted. We experience millions of these attacks every year. It's constant, and it really underscores the benefit that AWS Shield provides to not just the infrastructure, but all of the software running on top of it as well.
And so what's great is, there's a lot of this security that's built into the way that AWS runs their network. But like I mentioned before, we really care about the security of the Leo network as well. And so what we've done is we've added additional security and encryption on top of what's built in to the AWS parts that we're using. So one of the things that we do is when our antenna receives traffic, we basically put an envelope encryption on there, and we send it all the way through to our POP. And so this means, practically speaking, if someone was to go, break into the ground gateway site and try to, sniff the wire there, all they're getting is ciphertext, right? There's nothing there. If someone was to be a little more sort of ambitious and go into space and steal a satellite, also, they're just going to get ciphertext. And so the idea is across our network, we're using advanced encryption to make sure that we have encryption across our network. We also have a handful of some ISO specs, so ISO 27001 and 22301, for organizations that want sort of proof that we're doing things the right way and there's controls and other things. So security is built in kind of from the ground up and something we take really, really seriously.
Thank you. All right, so what are some of the unique challenges that Amazon Leo faced, and how did building on AWS help them solve it? Well, Amazon Leo is building this giant constellation in space, right? They're sending all this traffic up to it. But at the end of the day, the content still lives down here on Earth. Well, the AWS edge sites are advantageous in this way because they already exist in the places where Amazon Leo wants to send their traffic. By building on top of AWS, Amazon Leo can benefit from a terrestrial network that already exists. It also just so happens to be the cloud network that is the highest throughput and the lowest latency. AWS helps Leo provide its service in more locations faster. It allows them to focus on their core business challenges, like building out that giant satellite constellation and operating their lasers in space. Our edge sites are also advantageous because of their proximity to other networks. These facilities, they are where internet exchange occurs. It's where networks meet to exchange traffic with one another. But it's also where AWS deploys services, right? Services like CloudFront, ROF-D3, AWS Global Accelerator. These are services that want to be right at the edge of the network, right? They want to have very close access to these other networks so that they can be close to the users that may be requesting the content from these services. Now that Amazon Leo is built on AWS, they will also benefit from having this close proximity to these services and external networks. Having this close proximity to the networks and to the services is vital for a great customer experience. It drives down latency, and Amazon Leo is designing their service to be as low latency as possible. We know that the path from the antenna up to the satellite and back down to the ground gateway is already about 10 milliseconds, right? The path from the ground gateway into the Amazon or the AWS network can add another 12 milliseconds. We expect this to come down over time as those additional ground gateways are deployed, but at launch it will be about 12 milliseconds. We're bound by the laws of physics here. The data is being transmitted at the speed of light, and we can't make light travel any faster. So the only way that we can optimize latency is by limiting the distance that the data has to travel. That is exactly what Amazon Leo is doing. By deploying globally into the location where the internet exchange occurs, they are positioning themselves to be physically close to the content that is important to their customers, right? Whether it's the latest applications running in EC2, an on-prem network via DX, or the latest cat memes coming from the internets. The other impressive thing about that Amazon Leo gains by building on top of AWS is the amount of resiliency that is built into the service, right? We've already established that the AWS edge sites are present in the locations where Amazon Leo wants to send their traffic. That means they can deploy the ground gateways that they'll need and never be too far away from AWS. Since the AWS network is global, any of the ground gateways can be used to reach any of the Amazon Leo points of presence. If the ground gateways experience any problems for whatever reason, the satellite constellation can choose to send the traffic to a different ground gateway, and that ground gateway will be able to reach any of the Amazon Leo points of presence. We also see here that the ground gateways have the option of having redundant connections into the Amazon network. This can be especially handy if we run into one of the fiber-seeking backhoes. Even Amazon is not immune to the fiber-seeking backhoe. So if one of the paths get dug up, the ground gateway can simply use the redundant path to land the traffic into the Amazon network. Finally, by building on top of AWS, Amazon Leo has the ability to make their points of presence entirely redundant as well. By building on top of AWS, Leo has been able to build an impressive amount of resiliency into their service. That should allow you, if you choose to build on Amazon Leo, to build a very resilient service as well. I'll now hand back to Nick for the enterprise preview.
Cool, thanks, John. So yeah, one of the questions we usually get from folks is, hey, we're both Amazon companies between AWS and Amazon Leo. What does it look like? What are the integrations and what does that entail? So last week, if you missed it, we announced our enterprise preview. So it means we're taking interest from customers that want to start testing, and we're starting all that testing here very, very shortly. So let's walk through what it actually is going to look like to use Amazon Leo, and I can kind of show you what the integrations look like, kind of along that journey. So to start off, you can go to our website now. We're out on leo.amazon.com. You can click on business and learn a little about use cases and other things. When we go available, you'll be able to go from there and click into the Leo Enterprise Console. So the way that you log into that console is by using your AWS credentials. You can use, sort of IAM or SSO or your favorite way to log into AWS. From there, you'll log in and you'll get into our console. You'll see it looks a lot like the AWS console because we're using the same Cloudscape open sourced UI components, but it is, it's a separate URL. It's different. Once you log in, and as you're doing the account creation process, we're going to use a new feature that launched last week as well. It's called IAM Temporary Delegation. This allows the Leo network to ask for permissions into your account. So in this example, what we're doing is we're asking for requests to put CloudWatch metrics in, as well as EventBridge events, and some support functions for our customer support. And so you do this one time. If, for example, you don't have access to create IAM roles, you can also delegate that to your IAM administrator. So it's a cool feature. We're using that to essentially increase the amount of metrics in EventBridge that you'll get. From there, you can go through the ordering process. There's a few different components to this, right? So you'll choose an antenna. That's a one-time cost. You can then choose what we call the service plan. That's a lot like your cell phone bill. Happens every month. That service plan is going to be based upon multiple things. So you can get some in certain industries and verticals. You can also choose whether you want that networking to go to the internet or do private networking. So that's one of the forks you can choose as well. And from there, we can tell you what it costs and what that looks like. So it's a fairly standard ordering process. You do start with your location, so we can make sure that we have capacity there and that we are offering service in that way. Then, while that antenna is getting shipped out and you're getting ready for the installation, if you chose one of the private networking options, you can go set up your own IPv4 and addressing details. So if you're cloud people, this is kind of like the VPC for your satellite antenna things. And so from here, you can set up IPv4, subnets, CIDR ranges, and you can associate it with a gateway. So you can associate it with a gateway for direct connect or transit gateway. And those will allow you to connect directly to AWS or to that PNI that we talked about. Once the antenna shows up, the install's meant to be very simple. So maybe you put it on a pole mount or a non-penetrating roof mount, however you want to install the device, or the temporary stand, just put it in your parking lot, make sure it works. It will need to see the top 110 degrees of the sky or 35 degrees above the horizon. From there, it's a single Ethernet cable back into an indoor power injector. It does need to be a Amazon Leo power injector, just because there's some proprietary technology going on there. And then you connect that to the rest of your network. So you connect it to your switch, connect to a firewall, router, private 5G, it's Ethernet. You can do what you want. And so, and that's all very simple to do. The larger Ultra, and despite being a little bit larger, This one you might want like 2 people if you're kind of getting onto a pole, but otherwise it's very similar. So it's 110 degrees. No one's invented like 300 watts of PoE yet, so we do have a standard power brick, and then that has just a standard Ethernet coupler that's designed to be ingress rated for being outside. So same thing, you'll wire up the power, the Ethernet, plug it into your existing network, and you're off and should work. Then, as we all know, day 2 happens, and this is where we start doing management of things. So this is where your network operations teams and security teams and other folks, want to make sure that these things are being managed correctly. So I've got a list of some of the sort of the metrics and events that we're starting off with. Things like how much data have I used, the signal strength. I want to see the angle of the antennas to make sure someone hasn't kicked it over, or those kinds of things. These are available in the Leo console, but since these are also being shared through the AWS temporary delegation, you can also view these metrics inside your AWS account. And so if you want to build dashboards or automations, or your network operations team wants to get a page that sounds like a duck every time that something happens, you can use all the existing CloudWatch and EventBridge integrations into the rest of your environment. As well, all of our logs are going into AWS CloudTrail, so if you need to figure out who made that change or why something broke or whatever it is, that's there as well. From a billing perspective, pretty standard. This is, again, not in the AWS console, so you won't see it in the same billing area. You'll build a profile per country that you want to operate in. You have to enter your billing address and some other things that are country specific. The pricing is not released yet, so stay tuned. We'll have that more as we get into general availability. So I love all the folks out at AWS. There's a bunch of builders, and you guys want to build things and see how to use it. So now you understand all the background. Let's talk about what we're learning from customers. This is my favorite part of the job. I've been out here 3 years talking with folks about their use cases and what they can do, right? So for starters, it's pretty wide and broad, right? Leo, as a company, we're working directly to sell to consumers. We also have selling directly to enterprises, and we also have a sort of part of our business selling to governments. So that covers a ton of use cases. So you can think about almost every vertical you can think of: financial services, mining, the rescue and disaster relief, manufacturing. There's interesting use cases kind of across the board. So let's walk through, these use cases, but what's underneath these use cases and what's creating the new capabilities it really comes down to 3 things. So one is the performance. So you get a lot more bandwidth, a lot lower cost than you could do before. So what does that enable and what does that change, right? So there's some areas, if you're already using some bandwidth and you just have a lot more, it's easy. But there's also areas where it's so much more bandwidth that you can change the applications, the way you work, and just the how close that site even feels to you, right? One of the pieces of feedback we get from folks is to go, we'd love to put this type of workload or this application on the network, but we don't trust the other options right now, not enough. And so if you have critical infrastructure or other things that you need to go through security reviews and auditing and those kinds of things, that's a lot of what we're building for. And then it's just a location. If you're in a hard to reach place, that limits what you can do. So if you add up these kind of 3 factors, let's walk through how you can use it. So let's start off with the easy stuff. I've worked with enterprise long enough that no one does the hard stuff first. So we're going to walk through easy things and things that make sense to a lot of people. So, just providing internet connectivity to folks is really powerful. So if we take an industrial use case, we hear things like the guys don't want to go out on that oil rig unless they have full confidence that they can call someone when they need to. They need to make sure they can, and they want to talk to their families, and they want to just do basic things like that. Not a lot of complex architecture going on. So we get a lot of use cases like, hey, give the folks internet. If someone's doing maintenance, they want to be able to call someone that's good at maintenance, right? Or they want to use Salesforce or CRMs or whatever applications they use every day. It gets pretty far. Also, for whether you're a telco building cell towers and you're trying to get connectivity there for the first time, or you're someone like our own internal Amazon folks building distribution centers, getting day 1 connectivity there is difficult. It can take weeks or months. Amazon can ship devices much faster than that. And so you get an antenna, you stand it up, and you have day one connectivity. And then, yeah, day two, you can choose what to do with it. You keep it there for backup, or you move it to the next place that you need it. Then you think about sort of just education and sort of the underserved parts of the world, right? We're working with folks that go, hey, we're going to put an antenna there for maybe some industrial or business use case, but there's also, I don't know, a school there, or we think it's maybe in our best interest to add financial literacy or training to like the corporate uses that we're using as well. And so there's a lot of the things of just like internet to schools and countries that need it. So this is all just kind of easy things, low risk. As we get maybe a little bit further down, we can look at the architecture, right? So this is, it goes to the gateway. We taught you those things. And yeah, maybe you're using CloudFront for your gaming update, or you're using a corporate application in a data center, or maybe your learning application happens to be on AWS. And one of the interesting things that we talked about was, AWS doesn't take those things off the backbone. So it's basically like cold potato routing where it stays on that network the whole way. So if you're using applications that are on AWS and you're just doing the internet, it doesn't leave the network. And so you get benefits of this even without doing anything fancy. If we get a little bit fancier, the next thing we see is backup and resilience, right? So we've talked a lot about the backhoe, and again, cell towers are also not immune from these things. So if those goes down, you want another option, maybe, or to support microwave networks. In the industrial use cases, we see things like, hey, we're out in the middle of nowhere, and we're trying to get everything. We tried every cell carrier, we've tried every satellite provider, we've tried every fiber provider, and man, you just can't keep this site up enough. And so go to space. We have a different network. We have a lot of different ways that we work, and so this non-terrestrial network is a great way to add resiliency to applications that need to stay up all the time. In typical enterprise use cases, we see a ton of work with SD-WAN. You have multiple options, and Amazon Leo can just be another one of those that plugs into that. Then also the use cases around like disaster response. So we're working with folks that go, hey, we need to bring in a whole team of folks. They need to access medical records, or they need to do maybe like voice over LTE and communications when they stand up after some sort of event happens. And so they bring maybe some sort of case that's like pre-built in, and it's got multiple options, and now Amazon Leo is part of your go bag that you take out to these types of events. From here, this architecture is also fairly simple, right? So you can take your SD-WAN router, which already takes multiple forms of connectivity into it, and just add Amazon Leo to it. So then you can run the SD-WAN either in AWS, which a lot of folks do. You can also run it at your data center. And so it works pretty simply. Some folks we're working with want to do and add private networking into this. So essentially, you can add your Leo path to be fully private, so that can connect directly back to your data center via that PNI, or you can take it directly into your VPC and connect your SD-WAN there. So in this case, some of the benefits are you may not actually need an SD-WAN router. If all you need is that encryption and you need privacy, the antenna can do that. Alternatively, some people want to further secure their SD-WAN. So now you can run SD-WAN over private addressing, and that's one less thing that's exposed to the internet. Then we get a little bit kind of higher up. Let's do some harder things. So this is, in the industrial cases, this comes down to a lot of things like OT and critical operations. These things you don't want usually connected to the internet. And so what does that look like? We actually have a couple slides on this I'll walk through here in a little bit. One of the cases we see with telcos is they want to get rid of older 2G, 3G networks. So you can take those control planes, you can put them on AWS, you can run that network there, and now your transmission from your cell site and then back into your virtualized 2G, 3G core is all running on one network again. And so kind of an interesting use case. We see a lot of use cases, particularly since we work with AWS a lot, about data center resiliency. Those things need to be up all the time. How do we add Leo to this to make sure that we add more nines to your reliability story? And then also, if you think about remote healthcare, one of the examples we heard was, hey, look, in this country, there's not enough radiologists. Like radiologists are not distributed equally across the world. And so they want to find out, hey, can we do this virtually? Can we use radiologists from other countries, put an antenna at this hard to reach place, and now they have good enough connectivity, they can talk to doctors and healthcare experts in other places. So you can change medical outcomes through connectivity. So if we take a look at a couple of these examples, these start to get a little bit more meaty, right? So this is an example of, we call it the turbofan demo that we're running on our briefing center. And this is sort of a physical manifestation of the full Purdue model, right? So we've got full IT-OT separation that's going into a cloud WAN network. And so the idea is, most of the time for these types of workloads, you run those locally and you try to do that as best as you can. In some cases, that local site may go down. You've got sort of a site resiliency quantity of 1. So if you start to change this SCADA network and you start putting some of the components in the cloud, one, now you can start using that SCADA data in the cloud for interesting data lakes and analysis and other things. But two, you can start distributing that across the world. And so this model is have a backup for all your SCADA traffic, keep it separated, and move it to the cloud if you need to. But now that you've got resources that are running your local site remotely, you need to make sure you get to the cloud extremely reliably. And so here, you use whatever connections you can, and you add Leo as your resilient backup. And so we can connect directly into your private network, and it all, again, has some integration there. If we take a look at another example, so this is the kind of gold standard for Direct Connect, right? So if you want 4 nines of SLA offered from Direct Connect, this is what you got to do, right? So 2 ports at 2 locations each. When I see customers do this, usually like large mature customers get there and they can do this. But you're kind of looking at like a couple $100,000 usually, just depending upon routers and project managers and cross-connect costs and everything else. So not everyone gets there. So this is the 3 nines version of that. It's a little bit easier to get to, but still can be challenging for folks, particularly as you're just getting started. And so one of the things we're working with customers on is if you're trying to do a migration, you're trying to get into AWS, and your end goal is getting to the right inside that VPC, we can do this faster, right? Again, we can ship an antenna faster than project managers can figure out where a cable goes. And so you can use this for day one connectivity. Your application team, your developers are happy because they can get to that VPC where they need to send their traffic. And then you continue to do the work and you add the direct connect location. So that port shows up, great. And so now, if that, I don't know if that router has maintenance, so that goes down, you've got a backup path through Leo. And this continues to work, even as you add more resiliency. So if you get to the 3 nines or the 4 nines architecture, then you still have an additional, you're adding more resiliency to that through Leo. And so then we get into, I call these just transformation, because typically, if you think about people, process, and things, this is where you start changing the people and the processes, right? And so, we're still in enterprise preview, and so it's still early days, but these are some of the use cases we're hearing from customers where they think there's a big change to start changing what they're doing, right? If you take a look at, excuse me, if you take a look at some of these industries, right, manufacturing, energy, agriculture, they've been doing this for sometimes centuries out in the middle of nowhere with no connectivity. So the amount of people running around with pencils and doing it in a very reliable way, it exists, and you go, okay, well, what if you give you gigabit? What would you do with that? And they're like, well, it would take us a long time to figure that out, but it seems like we can do a lot of things. And so if you take a look at automation, right? So if you take maybe manufacturing, if there's a certain part of the manufacturing floor that's dedicated to running a local data center, if you have good enough connectivity, and if you can move that data center outside of that facility, or you just take the non-real-time stuff out, you get floor space back. But now you can start running more interesting applications that maybe require more computing or tied into central systems. So this can be things like process automation, or there's a lot of very interesting things, like for example, like Amazon does to do in our manufacturing and the way that we do logistics. But it takes time to get there, it takes connectivity. There's also then this question of where do you put the computing? So if you have strong connectivity to the outside world, do you need a local data center? We've talked with customers that go, we have a data center here just because that fiber to this area isn't very reliable. Maybe it's an island or something else. So we had to put a local data center there. If now you have strong connectivity, you can go, okay, well, I can use that connectivity maybe to put an outpost there. So I can put an outpost there, I can run the local computing, and it has enough link back to the cloud, it can work. But you might go, if I have good enough connectivity, let's just run that stuff on the cloud. I don't want to run the computing there. So we're having conversations like that with customers. Also, machine learning. I have not said the word AI yet, so sometimes people are pleased about. But we do see some very interesting cases where the data and the operations, the things you're doing in remote locations are valuable. So we'll talk about that one in a little more detail here. But then also, like, if you think about in-flight entertainment and things that move, what can we do now, especially if we add cloud applications to it? So this example is interesting. I've got a chance to go out on site with a handful of customers to really deeply learn about their use cases. And one of the consistent things we see is that there's always someone there that deeply, deeply understands like how everything works. There's a guy that can put his hand on the motor and tell you if the bearings are going bad. There's a guy that knows how the fish swim, and if like they swim like this, they're hungry. If they're fish like this, they're going to breed. There's a guy that can tell you that when the valve pump makes this sound, like it's because someone's abusing the system. There's all these and sometimes all they want is a camera, or if they want a microphone, or they want an infrared heat sensor, right? So if they just go, I just want the microphone. If I can get the microphone, I can send all that data to the cloud, we could do this stuff. So the idea is you're not taking this person away, but if you can send this data, you can get this data off of just being, maybe it's not even being monitored at all. You can start sending that through machine learning systems, you can start to do this stuff at scale, right? And so you're not talking about huge amounts of bandwidth sometimes, but you are talking about now, let's change the way that we're operating at that site, which again, they may have been doing for a while. And then you get into sort of the mobility use cases. So for example, we have an announcement we made with JetBlue, right? So how do we change their passenger experience? But also what's important is no one likes to pay a lot of money for flights. So how do you increase the efficiency of these things? How do you track the internals of the airplanes, right? If you take a look at maybe land mobility, if you look at something like mining, you would really like for these big expensive trucks that can cause safety issues to be maybe automated. So you don't have folks driving those things. But then how do you get there, right? You need monitoring, you need video, you need multiple layers of connectivity to make sure this is going to be safe. And then once you get there, it's a lot more productive. And also, I found out that people run data centers on boats. I personally wouldn't want to run a data center on top of salt water, but there's people that need computing and things out in the ocean, right? So, but that's also where a lot of things can happen. So how do you get your IoT data and your logistics data and all of that out? And so there's a lot of interesting things that we're going to be working on here. And then also one of the companies we're working with Hunt Energy, right? So if you take a look, a lot of the people we work with right now are utility providers. You talk about a business that's been around for a long time and have a low appetite for risk. It's those folks. And so they're a good use case because we're working on use cases like this. So we go, how would we change the way that we're doing power distribution locally and even across the world, right? It's something that's extremely regulated. And so if we want to do all this cool stuff on the right with AWS, we want to make sure we can do that reliably and simply. So this looks sort of like the turbofan demo that we looked at, where we can do HMI, we can do separation, we can put the firewalls in, we can pipe that in over into AWS. We have separate VPCs for operations and analytics. That's going into SageMaker and S3 for analysis. And then all your third parties that need to operate these things can operate in different accounts through Transit Gateway, and we get that scale here, right? So there's folks that really want to change, again, that change that's really hard to do that we're working with. And so, yeah, that's what we've got. So, to wrap this up, one, thanks for coming out. Two, I think, if I have anything to share with you is that there's a lot of ways to use this. Hopefully we've shown you some examples. You're all now satellite experts, so you can tell your friends. And so there's a lot of use cases that you can do. But you can start simply. You don't have to go into the hard stuff first, but we can also talk about that if you want to, right? So there's this path of continuum you can go through. We're in enterprise preview, so you can go and sign up for the interest list. We also have a booth downstairs. If you go down to the Venetian by the bus, we have a booth there. You can come talk to our teams, sign up for the interest list, those kinds of things. And yeah, thank you for coming out, and I'll be up here for questions. I'll also provide feedback. I read all that stuff, so if you want to see some more weird stuff in the next presentation, just let me know.